I'm going to walk through one method for looking for environmental contaminant data. This uh, process is probably not the most direct, but I found it kind of interesting when I'm researching some of the parameters we're going to propose in this class and ways to find good data from that. So just kind of starting from like, assuming I have no prior knowledge of where to find data, um, I started with just the simple search of glyphosate, which is Roundup, in concentration data, just like the simplest term we could put in Google and see where it takes us. And so I found a variety of kind of fact sheets and things that maybe are not the most interesting. But I saw this study here. This looks pretty interesting. And it's this USGS press release. And I think it's a good example of how we can go from a press release to the actual data behind the study. And that's what we want. We want the actual raw data so we can plot it and analyze it for ourselves. And so here's a short press release that just says, half of the 70 streams studied, glyphosate was detected, 80% of the times. Okay, great. But that's still not what we want, right? We want the raw data. So let's go to the actual study. And whenever you see a press release, I really like that this one included a direct link to it and it's open access. 90% of the time, they tend not to do that. And so I think it's really useful when you see a press release, and our university is certainly guilty of it, of not putting the initial study in there. So you have to go back and dig and see, okay, don't go on the press release, go on what the actual study was. This study's great, and I think it's kind of similar to where we want to go, and so I think it's worth looking at this study as a template uh, for the purpose of this project, which is to study a parameter in depth and kind of give its history and regulation and how it impacts aquatic systems. So we can scroll down, and here I'm really interested in the data. So I'm going to go to the materials and methods. And you can skim down and pretty quickly see, okay, they looked for concentration data based on existing database. It was publicly accessible. Perfect. So they use the USGS National Water Information System database. They even give a link to it. Good job, authors. Additionally, they say what parameter codes they were using. Now I'm going to copy and paste this one here, 62722. That's for glyphosate, and this other one's like another acid kind of associated with it, or breakdown product. But we're just going to go with this one for now. So let's go to waterdata.usgs.gov. Pretty simple. This system is super powerful and arguably difficult to use. And so it did take me a good 20, 30 minutes to click through and get to where I wanted to go. So if you start playing around in water data and you're not getting what you want, go back and look at the tutorial, and also just keep trying different things and try to get it figured out. If you click on a few things and 2 or 3 minutes later you're not getting what you want, keep going. Do some trial and error until you can get to what you want. So we're looking for water quality data. There's current conditions, historical observations, daily data. Now think about what this means. So this is mostly things like, this is USGS, so this is mostly things like stream flow, sediment, turbidity, salinity, temperature, oxygen, things like that. Things that you could measure, on a daily level. Well, glyphosate is not that. It's something that's more analytical. You take a sample and you go back to the lab. So these are probably not going to have necessarily what we want. Field lab samples is probably what we're going to want. So let's go to field lab samples. Let's say we care about Washington, and here parameter codes. So going back to the study, let's see if I've closed it here. It's right here. Going back to the study, it said using parameter codes. So we know that the authors of this study used parameter codes. So let's look for Washington and let's look for glyphosate and see what we find. So we'll submit that. We want to go down to Washington and paste our copy code in there, 62722. And we're only going to do one. I've tried to do multiple parameters. It's a bit clunky, and so I think going one code at a time. And if you want help finding the code, there's this here. So if you don't know the code for trimethylhalenes or whatever you're interested in, click on this help find the code, and it has all those codes in there. Table of sites grouped by, we'll just kind of leave that alone for now. Samples that include only the above parameter, okay. We'll go back to this and play with it a little bit more, but right now we just want to submit and see what we can find. So this should be giving us all of the Washington State water quality data sets that have glyphosate. It's resulted in 77 sites, and they're all listed here. Date ranges and the number of samples. Let's organize by the highest number of samples. So this is 1,400, and I think those are the samples of the overall database, not necessarily the samples of glyphosate, and I'll show you why I think that's true. So let's click on this site number, the Yakima River. And so now these data sets have been going on for a long time, since 1947. And we're going to try two different things depending on how it works. So first we're going to try tab separated data. Tab separated data is a way of saving text that can be opened in a wide variety of analytical software, R, and also Excel. So let's try that. If that doesn't work, there's one other thing we can try. Okay, it's downloading. Let me bring this in. So this is just the Mac text editor. This is, okay. So this is showing some data here. This is the site code. This is the date, time, and these are the parameter values. Okay, so we have some data here. Not a whole lot, but there's some. So now I'm going to walk through how to open this tab separated data. So I'm going to take you to my downloads. Here's the data file I just downloaded. And for Mac, it didn't give it a document code. So I'm going to add a .txt, which makes it a text file. And it's going to say, do you really want to change that? And I'll say yes. So now we can do two things. We can open it in Excel via this way of a right click, open with, and go down to Excel, and I'll show you another way to open it. And Excel is thinking. And it's popped up here. Okay, so now we're in Excel, and we have our metadata up here. So this tells us what all the things mean. Here's the interesting thing, the important thing, parameter 62722, glyphosate, water filtered in a 0.7 micron glass fiber filter, recoverable, and our units, micrograms per liter. So we can scroll down here. We have agency, the site, which is that site in the Yakima River, dates, times, and the actual data here. So it's this P62722. I don't know what this is. This is kind of irrelevant, I guess. And the actual raw data. And these are in micrograms per liter because the metadata told us that. The less than is below the detectable limit. So in 2002, the detectable limit was 0.1, and then by 2014, the method had changed, and so now the minimum detection limit is 0.02. So these would be called below detection limit. And then here's some actual data. So here's a little bit of data we can use. That's 29, 30 points of data that we can plot and analyze and then compare to things like the regulation limit or toxic limits, whatever comparisons we want to make. But here's a way of getting raw data from one site. I'll show you another way. Oh, my screencast is not showing it. Another way of opening data in Excel is to go File, Open, and then you can select that data that I've changed to a text file. See, this is why the other ones that did not have .txt after them, I'm not able to open those. So if I do it that way, it'll open. We have the same data. So that gives us, and we want to save this as a Excel file if you want to keep working with it. So that's data from one site. We can just go back and we can look at this Grainger drain. We could do the same thing. Download tab is separated values. Okay. Click on the name, scroll over, .txt. You can also oh, come on, of course, txt2, okay, dot text, okay, yes, add. You can also, didn't do what I wanted to do, sorry. You can also display these just on the website as well, so you don't have to download every one to see if it has good data. Like this one has way more data, so that's super useful. So same format. We can check the metadata again. Glyphosate water filtered, recoverable micrograms per liter. So here we've got 153 points of data, so that's quite a lot. So pretty quickly now we're up to 170, 180 points of data. Some of these are quite a lot higher, which is interesting. So what we can do is start collecting data through this portal, saving it, taking note of where it's at, and then start to use a analysis similar to this, where we're looking at those data spatially around land use practices, kind of a variety of different ways we can think about it, and compare that to both the regulatory or the human health or the aquatic health parameters for those data. So pretty interesting. I think it's well worth spending time with this web interface. It is clunky, it is a bit difficult, but once you kind of figure it out, then my advice is just download a whole bunch of data, save it, document it, and then you can start building your analysis around that, which will make your life a lot easier. So I hope that helps. I'll have some links in here, and this is the sort of thing we'll go through, but I just really wanted to show that process of, I really don't know what I'm looking for to finding a press release, to finding the peer-reviewed data, the peer-reviewed publication, and then finding the data behind that. And that's really what I want to see is, and what we need is that raw information, those raw data that we can then start to plot and play with. So hopefully that's helpful. Thank you.